up and do that. Okay, so 2.5. Okay, so long division stuff. Yay. We're also going to learn about the factor theorem and the remainder theorem. Okay, so those of you taking notes and want to have, whoops, let me back that up. The essential question will be, if you know 1 0 of a polynomial, how do you find the other 2? Or the other 3 or the other 4 that are missing? So we're going to learn how to find these zeros, because not always do the polynomials factor so well. Sometimes you might have to use the quadratic formula again and things like that. So this part of the essential question will be answered in part 2. Okay, so you won't see that one until tomorrow. So part of our essential question is how do we do long division and those kind of things. So, well, let's get started with part 1. What I want to do is review the procedure for long division, because algebraic division is very, very similar. Very similar. And some of you guys just learned this and you don't really think about the steps that are involved. So as I go through the long division here, I want to remind you the steps that we're doing. Okay, so if I remember correctly from 4th grade or 3rd grade or whatever grade it was, when we did long division, what grade did you guys learn long division? 2nd grade? 1st grade, how about that? Now maybe 3rd or 4th grade, right? Long division? Yeah, you guys remember these fun things? So, you remember how it works, right? You look at this number and you say, how many times does it go into here? And obviously 5 does not go into 1 because 1's smaller, right? And so normally what you could do is put a 0 there, right? But we leave the zeros off, right? So we move over to the next number over and we go try this one instead. And we know 5 does go into 12, and we say it goes in twice, right? So you put a 2 right here. And you put the 2 right above the 2 here, right? That looks right. And what do? You then take this number and you multiply. You multiply here, right? And you get 10. And then what do? You subtract. You subtract. You will be surprised that algebraic long division is just like this. You see this step here? And then you subtract and you get what? 2, right? And so then you drop the 6. Yeah? It's amazing how similar long division algebraically is the same idea. So now you say, well, how many times does 5 go into 26? And you're going, oh, 5. And we put that 5 right above the 6, right? And 5 times 5, of course, is 25. And then what do? You subtract, right? And then we get a 1. And when we bring down the 4, right? And you just keep going, right? Now, what happens at the end if there's a remainder? Well, let's continue and find out what happens. So I'm kind of curious here. So you guys might have to teach me. I forgot how to do this, right? So 5 goes into 14 twice again. So we'll put the 2 over the 4, and we put a 10 here. Right? And we put a 4, and then we bring down the 8. But notice each step along the way we're subtracting. And then 5 goes into 48. I think that goes in 9 times. So when we put 45, and we do this, we get 39. Right? Long division. And 5 goes in here how many times? 7, right? And so we have 35 here. And finally we subtract. And we get 4. And this would be our remainder, right? And we call this remainder 4. But you can also think of it as so you can think of it as like 4/5. There's like 4/5 left. And you can sometimes write it in decimals. Okay, so now what do we call this number up here? This is called the quotient, isn't it?
Oh my God, Priscilla got that. She said that.
I think it's called the quotient. I think. I always forget sometimes myself. Been a while since I've been in 5th grade or 4th grade. Well, so we have the divisor and the divisee and the remainder and all this cool stuff. Okay, so now you will be surprised how similar these steps are with algebraic. Like when we have x's in here instead. What happens when we have x's in here? Well, that's what I'm about to show you. But if you understand this algorithm, the algorithm's the same, very similar. So please, I've always found this kind of easy, but people, when they start doing algebraically, they go, oh my goodness. What I would recommend is that you give your full attention to watching right now.
Take notes.
Don't take notes, just watch. Because if you understand the algorithm, you will be able to do this. It's not terribly hard. Okay? And then I have some news for you. In some cases, we'll have shortcut method that involves synthetic substitution. You guys remember that? We did that back in the earlier section in the chapter. We will do a synthetic method as well. So stay tuned for that. Alright, so please just pay attention to how the algorithm works. And you'll notice how similar it is to the one I was just showing you. Now do you see this here? Remember how we had 5 gazenta? Gazenta? That means goes into. Gazenta. And we had something like, I don't know what.
I heard that too.
We had like a 1, and then we had a 2, I don't know, an 8, 4, 9, or I don't know. And remember what we did? We found out how many times you multiply this, how many times can it go in there? Twice. Alright, so now look at the similarity. What I do this time is I take this number here, and I say, what do I multiply to get that? You ask yourself, what do you multiply by to get that? Exactly. And you say, oh, x times x squared. And so you put the x squared right on top. Bam. And remember what we did? We said, oh, this goes in twice. And what did we do right after that? We took this and multiplied it by that. We multiplied, right? The same is true with this. You take this and you multiply it by the whole thing here, though. You multiply it by the whole thing. And what do you do then? You put it right underneath. Right? You put it underneath. So we put the 10 right there. Here, you multiply this one by here. X times x squared times x gives you x cubed. Now let me just clean this up here. Alright. X squared times x is x cubed. You put that right underneath. Right? X cubed. And then you multiply by this one. You get minus x squared. Right? Yes, Joel.
So why didn't it fit in there 3 times?
Why didn't it fit 3 times?
Why didn't it fit like x cubed?
Oh, because x cubed times x is x to the 4th power. Okay, so what you want to do is be able to multiply and get the exact number if you can. Like, for example, if this were a 10, you would get the exact number, right? Okay? Well, so what we want to do in this case, when we're doing algebraic ones, we want to get the exact expression right here. And it turns out x squared does give us that. However, what's the next step? The next step over here was what? Subtract. Right? Well, the same thing you have to do here, and this is the step that most people forget when they make mistakes. You have to subtract. You see that? You have to subtract this, and people make mistakes right here. They don't subtract. And basically, subtraction just means change the signs. So what I'm going to say on this step, I'm going to say change the signs. Okay, so let me back up here. I'm going to back this up just a little bit. So the next step, I'll tell you how I do it. I draw this line across, and then I'm going to write it out big here. Change. Oh, you can't see this? Oh, that's horrible. Change the signs. You guys can see that okay? So what I do is I go through here, and this one's positive, so I make it a negative. This one is negative, so I change it to a positive. Does that make sense? And after you subtract, what do? You then do your addition or whatever. And so in this case, we had a 2 sitting right here, and so we ended up with a 2. Well, if you subtract here, notice what happens. This one subtracts off. That one's gone. And here, what do we get? Oh, that crosses off too, doesn't it? And so there's a 0 for this part. So what do we need to do? Change my color. How about white? Would white work? Get a 0 here? No. How about blue? Blue? Blue. We get a 0 there. Since there's zeros here, what do? We bring down this one. And we bring down a 3x plus 2. Okay, so now you repeat the process all over again. You say, well, what do I multiply this by to get exactly this? What do we multiply by? 3. So now you're going to put a plus 3. And you're going to put it right above the term that you're dealing with. Okay, so now what do you have to do? You see, here's the key step. This number needs to multiply by this. And the same is true here. This number, isn't there a better color? Can I use this cool green here? You got to take this number here and multiply it by this down here. And you got to multiply both terms. So 3 times x gives you 3x. And 3 times negative 1 is negative 3. Now, watch a step. Now again, if you just watch the algorithm, you're going to get it. Draw your line across. And then change the signs. So I'm going to change this one to a negative, change that one to a positive, and so these subtract off, and so I'm left with a 5. Okay, and now you notice that x does not go into 5, right? And so this is where you have your remainder. And so what we're going to do is we're going to write a plus sign, and we're going to write this as 5 over x minus 1. So this looks a little bit messy here, but the quotient up here, the quotient is x squared plus 3 plus 5 over x minus 1. Now, if you do this 3 or 4 times, you should have the algorithm memorized. Okay? So, what I want to do now is a few more of these, okay? Ready? So we'll do another one. Now what I recommend is kind of like our synthetic division. Sometimes I like to add in zeros. So you'll notice on this polynomial over here, there is no x squared term here. No x squared term. And so this is what we mean. If there's any missing terms, just put it in as a 0. And the 0 acts like a placeholder. It holds the place for the x squared terms. Now I'll show you what happens on this one. When you're subtracting underneath here, you want to line up these monomials under the like terms above. And so watch what happens. Okay, so again, to show you the procedure again, we want to figure out what do we multiply this by to get exactly that. We're going to need a 2. What else? We need an x squared. We need an x squared. That would give us exactly 4x cubed. Okay, so then let's see what happens. What you need to do then is take this. You're going to take this 2x squared and you're going to multiply it by this binomial out here. And you're going to place them underneath. And you're going to line them up with the like terms. Any of the like terms up here, that corresponding like terms. So let's see what that would look like. So 2x squared times 2x gives me 4x cubed. So I put that one underneath this one because these are cubes, right? And I multiply this one times this one, right there, and I get negative 6x squared. Do you see now why I wanted to have an x squared underneath here? There was no x squared under here, so where do I place it? You see? And so if I didn't put in this 0 here, I would have nowhere to put it. Does that sort of make sense? And so by putting in a 0, you kind of have a placeholder here for the x squares when they come up. Make sense? So add in some zeros if you need to for the missing terms. Okay, well, so now here's the step people forget. What do we do? Change the signs, right? What we need to do is go back to my cool. Well, let's try this pink one. We draw a line across, and then we change the signs. This one was positive. I change it to a negative. Change this one to a positive. And so then we add. So of course these are gone because they're opposite in sign, and then 0x squared plus 6x squared gives me a 6x squared. And then I bring down the next term, minus 3x.
First term always cross out.
Well, yeah, that's why you made it so that they'd be exactly the same. So that when you change the signs, they'll be opposite. This one's positive, this one's negative. Okay, so now we repeat the process. You're looking for a number right here that gives you exactly 6x squared. And hopefully you guys can figure that out quickly. What number do we need? Well, we have a 2x here. Looks like we need a 3. And this is an x squared, that's an x. Looks like we need a 3x. Now is it positive or negative?
Positive.
It's positive. So make sure it's positive. Okay, you guys good with this? Okay, so now you do the multiplication part. What you're going to do is take this and multiply it by both of these numbers inside of here. And after a while you get used to this algorithm. You know you're going to get this one exactly, right? So that's going to be 6x squared. 3x times 2x is 6x squared. And then 3x times negative 3x is negative 9x, right? And we draw our line across and we do the thing that people always forget. Change the sign. So this one's negative. And this one's positive. And so when we add, those two are gone. These are gone. Okay, and we get a positive 6x. And we bring down the next number. Plus 5. Everybody good so far? Is this making sense? Yeah? Okay, so now we repeat the process again. Let's see. We need to get 6x here. Now all we need is a plus 3. Okay, so we take our 3 and we'll multiply it here. And we end up with a 6x. And 3 times negative 3 is negative 9. We'll draw our line across, and I'm going to change the sign. So this one becomes negative. This one becomes positive. Okay, and that gives me a 14. Now an x is higher degree polynomial than a 14. So the x's aren't going to go into a constant, right? It's not going to go into this. So that's my remainder. Now the way you write your remainder is you put another plus sign and you write this as a fraction. 14 over whatever you're dividing by. And so then you're going to have a 2x minus 3. And so this whole thing here is your answer. I always forget what this is called. We'll just call it the answer. Divisor, dividend, and quotient. I don't know. It's hard for me. A quotient I know means divide. Alright, so what do you guys think? Is this terrible? Alright, do me a favor. If you have your book, what I want to do now is stop and give you an opportunity. We're gonna start part 1. So if you have your book, what I want you to do is about 2 or 3 of these on your own here. I'm gonna give you about 5 minutes to start this. What I want you to do on your assignment, if you look at your assignment sheet, what are we doing for part 1? If you look at your assignment sheet, we should be on. By the way, you're going to do this all as one assignment. You're going to staple it all together. But you have 3 through 17 odd. So maybe what you can do for a few moments, I'll give you about 5 minutes. Why don't you do 3, 5, and 7? 3, 5, and 7 from your book. By the way, there's no study guide for this section, okay? So you can start the book assignment. And what I want you to do is 3, 5, and 7. And give you about 5 minutes right now. So I'm going to pause. Okay, so now I want to show you synthetic division. It's very similar to synthetic substitution with one small change. You guys remember when we were doing synthetic division? We set up these coefficients, right? And we set up a little box here. Remember that? So what we do is we start out the same thing. We're going to put a 2, a 1, -8, and 5. And just watch this and you might be amused by what this does. Now, by the way, we're going to put a 3 here. That's that number right here. Does that make sense? However, you notice how we do this subtraction all the time? You see that subtraction that we have to keep doing? Synthetic division will work if we change the sign. That will take care of all the subtraction. Does that make sense? Well, what I'm going to do is this little zigzag pattern. And if I change the sign, already right here, then I won't have to worry about changing the sign again. Does that make sense? It's like I have it built in. Just watch and you'll be amused by this. Okay, so we start off like synthetic substitution, like we were doing in section 2.1. We drop the 2 down and we put a 2 here. Right? And you get a negative times a positive here, and I get -6. Now notice I don't have to change any signs as I go. I just go straight on through, and like we did before. And so I get -5 here. And I multiply this one times this one, and I get +15, and I get this, and it's positive, right? And now I get a +7. And so I'm going to write that as a +7 if I want. And then a negative times a positive is -21. And I get a -6. Now, if you just take a look at this for one moment. 16. Oh. Alright. If you look at this and you look at this, you might be amused. There's your 2, there's your 5, there's your 7, there's your 16. So guess what? You can do long division by using synthetic substitution as long as you change the sign on that number right there. Make sense? Okay, see, so now here's the tricky part. You have to make sure you write this correctly. This is going to be 2x squared minus 5x plus 7 minus 16 over what? It's over your original thing here. You got to remember that. It's x plus 3 here. Does that look simple? It is pretty simple, so I'll show you it again. Now, you do have to keep things straight. And don't confuse this with what you're doing before called synthetic substitution. This here is going to be called synthetic division. What we're doing before was called synthetic substitution. And the really only difference is you change the sign right here of this number here. So let me show you a few more of these, and I think you'll kind of like this. Let's see here. I just need to go back to my PowerPoint. And let's continue on here. There's the synthetic division. By the way, you can read it in your book. Okay, so this one. Alright. Very similar to the one we just did, I think. So let me get my pen out here. And again, I recommend just watching right now, because really what you want to focus now on is just the algorithm. Make sure you understand the algorithm. And then in a few moments, I'll give you an opportunity to do 3 problems again in your book. Alright, you guys ready? So, the way this works, you create... Oh, man, I knew that was going to happen. I hate that.
On this.
Oh, there we go. I'll change the pen. Okay.
On these type of questions,
Yeah.
do they ever have like the pattern missing?
They might have a 0 missing. If they have a 0 missing, you got to put it in, just like before. So, to take care of all those subtraction steps, you can just change the sign on this. So you make your little box again and put -3 here. And then once again, you put all your coefficients here. And you watch for zeros. If there's a missing term, you got to put a 0 in. So you're going to put a 2 right here. A 1. A -8. And a +5. That's not the one I just did, is it? Yeah, it is. So let's do a different one. So, alright. So, that was boring. Let's try this one now. Okay, so this one's different. Alright, so we'll put a little box right here. But this is a -3 still. Okay. But this time we have a 3, 17, 21, and a -1. Now, by the way, when you get down with this step here, this step here is a little tricky. What you have right here. So remind me, I'm going to share you a little secret.
Make sure you go out of 1.
What's that? Oh, that's -11. -11. Alright, so again, you do the synthetic division. Ready? It's called synthetic division. It's very similar to synthetic substitution. So we drop the 3 down, right? And then we go through and do the zigzag. And so we get -9 here. And we get, what, 8? And then we get, what, -24? We get -3. We get +9. And we get -2. Now, some people get confused. How do we write this as a polynomial? Now, here's what I want you to think about. Think about this for a second. If you're dividing by x minus 3, and you had a 3x cubed here, wouldn't this x cancel off here and give you an x squared? Does that make sense? If you could remember that, then you know how this starts. It's going to be 3x squared, x, and 3. Then what's this 2 over here? This is the remainder part. So you write it as x. Is it x plus 3? You write it exactly as what you had there. X plus 3. So this part is what we call the remainder. That's all there is to it. I mean, it's really easy. So, and so I think your first couple problems are going to be the long division way. Your next 3 or 4 or 5 problems are going to be the short synthetic division way. So again, you're just doing 3 through 17 odd for part 1. You can go ahead and spend the remainder of the period working on this. And then tomorrow we'll do part 2, okay?